Whew. Okay, sorry about running a little bit late. I was up late last night working on some stuff. Honestly, I probably should have gone to bed way earlier because it did not finish and I was falling asleep at my desk. But everything should be all connected. Ooh, let's put the background music on. Okay, excellent, excellent, excellent. Everything should be good. Where is my... There we go. It's too early for Unk. Yeah, which reminds me, I forgot to open up the chat. I've been trying to use Restream's chat app. It works okay. Better than the integrated thing that's Oh, yeah. Oh, good. It's got to go through and read all of them. Okay. So, what we're doing today, let me know if you can hear the music or if the music's too loud or anything like that. You know I'm like super self-conscious about that stuff. But anyway, we're going to look through this stuff. Again, we may or may not watch the whole video. We probably will watch the whole video. But just know that it's always possible that we won't. Let's get into it.
The video for the quiz to test your knowledge of the material in this video. Also, remember to download and use the Anki flashcards with the link in the description, which will help you very much in your study.
I'm doing this stuff early in the morning because it's kind of boring.
This is the fifth lesson.
Studying.
And now we're going to get more into the details of how data travels through a network.
Study stream?
This time we'll focus on Ethernet LAN switching. So if we look at this simple network consisting of a few PCs, a switch, and a router connected to the internet, today we'll be looking at how data moves around between the switches and the end hosts connected to them and to their router. How data is sent from the router to other networks will be a topic for another video, but let's start small. First, let's review. This is a slide from day 3's video of describing the physical layer of the OSI model. The physical layer defines physical characteristics of the medium used to transfer data between devices.
So we kind of talked about this last time, if you remember. This is the OSI model. This is outdated. We don't really use this model in terms of like protocols, but we use it in terms of our everyday talking. And basically the TCP IP protocol that we use is more or less the same model, except it like groups things. Like all of these three are grouped together. And it kind of, because the OSI model has some issues with it, with like certain things seeming like it's going in the top and it's going in the bottom and stuff like that. So that's one of the things that's going on with that. Okay, let me make sure I can hear the music.
For example, voltage levels, maximum transmission distances.
Okay. I'm just always... Ooh, damn. Ooh, dang. Oh, my phone. I don't know how to do a sound check yet. I need to figure that out before I go live. I just don't know how to do it. Anyway, so that's what's going on with this.
Like Ethernet UTP cables, 100 meter limit, physical connectors, cable specifications, etc. Digital bits are converted into electrical for wired connections or radio for wireless connections signals. All of the information in day 2's video,
about the physical
cables,
layer,
pin layouts, etc., is related to the physical layer. So we've covered a good amount about the physical layer, learning about copper UTP cables, fiber optic cables, RJ45 connectors, etc. Let's also review this slide about layer 2, the data link layer, from day 3's video.
It's going to be like switches, MAC addresses, things like that.
Layer 2 provides node-to-node connectivity and data transfer. For example, PC to switch, or switch to router, or router to router, etc. It defines how data is formatted for transmission over a physical medium. For example, copper UTP cables.
Maybe that'll help.
It detects and possibly corrects physical layer errors. It uses layer 2 addressing, which is separate from layer 3 addressing. Remember, IP addresses are layer 3 addresses, not layer 2. Switches operate at layer 2. So in this video, we'll be talking...
The best way to not get confused between the data link layer and the network layer is that data link is switches in switches just reroute traffic in a local area. So like in my closet behind me, I have like my whole like router and everything set up for the house. And that just reroutes all of the devices in this house to my router. The router is the gateway to go outside of my house. A good way to think of it is like, like a school. Okay, a school has its interpostal like I can send mail if a school district has 5 schools, and I work at school number 2, and I need to send mail to school number 5, I don't have to go to the outside U.S. post office. We have our inner system as it is. That's the equivalent of the data layer. That's our data link layer. That's the equivalent of a switch. We handle all of our internal affairs that way, and then if I need something to go out, then I go to the post office, or I used my internal system to go to the post office.
About Ethernet LAN switching, and Ethernet involves layer 1 and layer 2 of the OSI model. Since we've already covered the layer 1 Ethernet standards like UTP cables, this video will be about layer 2. Then, as we continue with this series, we'll move up the layers of the OSI model until you get a complete image of how data is sent and received over networks. Now let's talk about what a LAN, or local area network, is. There are different ways of defining a LAN, and your understanding of a LAN will become more complete as you learn more and more about networking. But basically, it's a network contained within a relatively small area, like an office floor or your home network. Routers are used to connect separate LANs. Look at this diagram. How many LANs do you think there are?
There's 3.
Well, by the definition I'm using, this
1,
green
2,
network,
3, 4,
consisting
5.
of 3 PCs, 1 switch, and the router interface they are connected to, is 1 LAN.
Well,
this red
no,
network is also 1
we would
LAN.
group them.
Although there are 2 switches, it is all 1 LAN.
Yeah,
Switches
the
do
switch
not
doesn't
separate
make the
LANs,
LAN,
but
it's the
adding more
router that makes
switches
the
can be
LAN.
used to expand
the
an
router's
existing
the
LAN.
gateway.
So these red devices are part of 1 large LAN. Now, what do you think about the blue devices?
This is special because this one, both routers aren't speaking to each other. They're going to the both switches aren't speaking to each other. The only way they can talk to each other is through the router. So this is isolated from this, which would make this its own LAN and this its own LAN. Let's see if I'm right.
There's the same devices as in the red network, but instead of the switches being connected to each other, they are connected to different router interfaces. So that means they are 2 separate LANs. One for this switch, its end hosts, and their router interface, and one for this switch, its end hosts, and the router interface they connect to. So in this lesson, we'll look at how traffic is sent and received within LANs like these. For example, this PC in LAN 2.
This model of like a router, like these with these layers, where it's the router, the switch, and the computer. This is the most basic outline for infrastructure ever, and it just gets bigger. So like for instance, you'll hear me say all the time that everything's everything. This router is the boss. The switch is the manager, and then the devices are the employees. Like, this is the principal, this is the teacher, these are the students. Like the model of the I don't know what to call it, the hierarchy tree of systems, I guess. I don't know. Maybe there's some term for it or something like that. It would probably be way too much work to actually figure out what that term is. It's not important. My point being is that you have to start looking at these things in terms of real life connectivity. And I don't mean connectivity through network, but like you got to connect them to other stuff. You know what I'm saying? You have to start making analogies and connecting how all of it comes together. I'm doing a horrible job of explaining it. Maybe I'll think of something better. Let's keep going.
To another PC in LAN 2. But we'll leave the topic of sending data between LANs for a later video. Here's one more bit of review. This shows the encapsulation process as data is prepared to be sent over a network.
PDUs, we went over that last time.
At the top, the data prepared by the upper layers of the OSI model is simply called data. A layer 4 header is added, and this combination of data and layer 4 header is called a segment. A layer 3 header is added to the segment, and it is now called a packet. Finally, a layer 2 header and trailer are added to the packet, and it becomes a frame. Once again, these different stages of preparing data to be forwarded are called protocol data units, or PDUs. For example, the layer 2.
Now, in his that he had last time, he had these reversed where the header was on this side and the trailer was on this side. I don't know if that matters.
PDU is a frame. Today we're going to focus on how switches receive and forward frames, specifically Ethernet frames, since it's the layer 2 protocol used in virtually every LAN in existence today. Let's take a look at the actual contents of this Ethernet header and trailer. So here's an Ethernet frame encapsulating the packet with a header and trailer. Note that I put the header on the left and the trailer on the right, opposite of the previous slide. Let's look at the header. Don't worry, I'll cover these in more detail, but here's a quick rundown. There are 5 fields in the header. First, the preamble and SFD, which means start frame delimiter. These are used for synchronization and to allow the device to be prepared to receive the rest of the data in the frame. Next is the destination, the layer 2 address to which the frame is being sent. Next, there is the source, the layer 2 address of the device which sent the frame. The final field in the Ethernet header is the type. It indicates the layer 3 protocol used in the encapsulated packet, which is almost always Internet Protocol, or IP, version 4, or IP version 6. However, sometimes this is a length field, indicating the length of the encapsulated data, depending on the version of Ethernet. Now, the Ethernet trailer has only one field. That's the FCS, which stands for Frame Check Sequence. It's used by the receiving device to detect any errors that might have occurred in transmission. Okay, now let's take a look at these fields in more detail, starting with the preamble and start frame delimiter. Here are the first 2 fields, the preamble and SFD, which I like to think of as a set. Let's look at the preamble first. It's 7 bytes long. How many bits is that? If you remember, there are 8 bits in 1 byte,
times 7,
so
64?
7 times 8 is equal to 56 bits.
Oh, no, 64 would be 8 times
It's
8.
a series of alternating 1s and 0s, like this. 1 0 1 0 1 0 1 0, which is 1 byte, 7 times. The purpose of this is that it allows devices to synchronize their receiver clocks, to make sure they're ready to receive the rest of the frame and the data inside. Okay, that's the preamble.
It's so
now
wild
the
to me.
SFD.
Like, how does that...
SFD stands for Start Frame Delimiter.
Like, how does it know?
Its length is 1 byte, or 8 bits.
It's magic.
Its bit pattern is 10101011, similar to each byte of the preamble, but the last bit is a 1, not a 0. It indicates the end of the preamble and the beginning of the rest of the frame. Now let's look at the next 2 fields, the destination and source fields. They indicate the devices sending and receiving the frame. Like when you send an email, both the destination and source email addresses are included in the email. Or when you send a letter in the mail, although that's getting less and less common these days.
Did you
The
just
addresses used in
believe-
Ethernet are the destination and source MAC addresses. MAC stands for Media Access Control. The MAC address is a 6-byte, or 48-bit, address of the physical device. This is separate from a logical address, like an IP address. The MAC address is actually assigned to the device when it is made. I'll talk more about MAC addresses in a few slides.
Well, hold
But
on.
let's move on to the-
hold on. Indicates the device sending and receiving the frame consists in the destination of the source MAC address. MAC address is the media access control. It is 6 bytes, 48 bits. Address of a physical. Okay, yeah. I knew all that. Okay.
remaining fields of the Ethernet frame. The last field of the Ethernet header is the type or length field. It is 2 bytes or 16 bits in length. It can be used to represent either the type of the encapsulated packet or the length of the encapsulated packet. What do I mean by that? Well, if the value in this field is 1500 or less, that means it is indicating the length of the encapsulated packet in bytes. For example, if the value in this field is 1400, it means that the encapsulated packet is 1400 bytes in length. However, a value of 1536 or greater in this field indicates the type of the encapsulated packet, which is usually Internet Protocol version 4 or version 6, and then the length is determined via other methods. For example, a value of 0x0800, which is written in hexadecimal and is equal to 2048 in decimal. The 0x in front of 0800 is used to indicate hexadecimal, by the way. I'll talk more about hexadecimal in a few slides when I talk in detail about MAC addresses.
Okay, I feel like I'm just getting
2048
information.
is greater
I
than
need to know what this is
1536,
and
of
how to
course,
apply it.
and it's used to identify that the encapsulated packet is an IPv4 packet.
Okay.
0x86DD, which is equal to 34,525 in decimal, is used to indicate that the encapsulated packet is an IPv6 packet. Okay, so those are all of the fields in an Ethernet header. Try to remember the lengths of each field. The preamble is 7 bytes long. The start frame delimiter is 1 byte. The destination is 6 bytes, as is the source, as both are MAC addresses. And the type or length field is 2 bytes. Now let's take a brief look at the only field in the Ethernet trailer, the FCS, or frame check sequence. The only field of the Ethernet trailer is the FCS, which, as I mentioned, stands for frame check sequence.
Okay.
It is 4 bytes or 32 bits in length.
Okay.
Its
I'm
purpose is-
starting to kind of understand. So this is the PDU, And then this is the crap that is put onto the packet to turn it into a frame. And now we're talking about this chunk of the frame, which is the FCS, the frame check sequence. Detects corrupted data by running CRC, an algorithm over the received data. It's pretty insane, dude. Like,
to detect corrupted data by running a CRC algorithm over the received data. CRC means cyclic redundancy check. Cyclic refers to something called cyclic codes. Redundancy refers to the fact that these 4 bytes at the end of the message enlarge the message without adding any new information, so they are redundant. And check refers to the fact that it checks or verifies the data for errors. Don't worry about the details of CRC too much, just be aware of the term. And remember that the Ethernet frame's frame check sequence is a cyclic redundancy check. If you remember that, you should be good for the CCNA. Feel free to read around on Wikipedia if you're curious to learn more about cyclic redundancy checks. Okay, now we know all of the fields of an Ethernet frame, both the header and the trailer. Try to recall the length of each field again. The preamble is 7 bytes.
1, 6.
The start frame delimiter is 1 byte. The destination is 6 bytes.
Source.
The source is 6 bytes also. The type or length field is 2 bytes.
Damn, dude, am I going to be expected to memorize that? Okay, so preamble is 7, SFD is 1, destination is 6, source is 6, type is 2. See, okay, this is how you like memorize things. 1. What are you doing? This video belongs. Yeah, it does. Yeah, we're watching it. Like, yeah, we're learning, and then we're gonna do his packet tracer after this too, and then we're gonna do his Anki flashcards after this as well. Yeah, you should definitely subscribe to Jeremy's Lab. He's like amazing. Anyway, so the what I struggle with is like, okay, so like this is 7 bytes, right? Why? Like, why is it 7? Like, what is the significance of this being 7? And why do I need to have it? Are you Jeremy's No, I'm not Jeremy's Lab. What are you talking about, dude? Like, we're just here trying to learn this stuff. Like, we're just watching a video, man. So the preamble 7 and the SFD is 1. So how, like, what is the significance? Like, why do we need it to be 7? So let's see here. In a Ethernet frame, why does it matter? Why does it matter to know the, what is it, bytes of things like the preamble? See what it says. Simple answer. I don't know if this is gonna pick it up or not. I bet it will if I put it in here.
One. Simplified answer. It matters because the byte sizes tell you how Ethernet physically organizes data on the wire. For CCNA, you do not need to obsess over every byte forever, but you should understand the basics because frame sizes affect how devices recognize the start of a frame. Minimum and maximum Ethernet frame sizes. How much overhead Ethernet adds. Why some frames are considered valid or invalid. How troubleshooting tools display Ethernet traffic. The preamble specifically helps the receiving device get ready to read the incoming Ethernet frame. 2. Analogy. Think of an Ethernet frame like a letter being mailed. The actual message is the data, but before the message arrives, there are other parts. A signal that says, a letter is coming. The destination address. The source address. The contents. An error-checking stamp. The preamble is like someone knocking on the door before handing you the letter. It is not the actual message, but it tells the receiver, wake up, get ready, data is about to start. In Ethernet, the preamble gives the receiving device time to synchronize its timing so it can correctly read the bits that follow. 3. More in-depth answer. An Ethernet frame is made of different fields, and each field has a specific size. A common Ethernet frame layout looks like this. One important CCNA detail. The preamble and SFD are often not counted as part of the Ethernet frame size when people say an Ethernet frame is 64 to 1518 bytes.
Whoa.
The standard,
Okay, hold on. Say that
the
again.
preamble and SFD are often not counted as part of the Ethernet frame size when people say an Ethernet frame is 64 to 1518 bytes. The standard Ethernet frame size is usually counted from destination MAC through FCS.
So that means that when people are talking about, the preamble is not included into this, or it is included into it, but when people talk about it, it's not included, because that's what I just said, and we might need to look that up further.
So, minimum Ethernet frame. Destination MAC. 6 byte source MAC, 6 bytes type length, 2 bytes payload, 46 byte TSFCs. Maximum standard Ethernet frame. Destination MAC, 6 byte source MAC. Destination MAC, destination MAC. Destination MAC, if there is an 802.1 Q LAN tag, 1,582 bytes. The reason these byte sizes matter, or too large, may be treated as an error. For example, so knowing the field sizes helps you understand what the switch or router is complaining about when you see interface errors. 4. Real-world scenario. Imagine you are troubleshooting a switch port at your college help desk job. You run, show interfaces, and you see errors like runts giants or input errors. Knowing Ethernet frame sizes help.
Runts are frames that are too small. Giants are frames that are too big.
Ethernet frame sizes helps you understand what those errors mean.
Okay.
If you see runts, the switch is receiving frames that are too small. If you see giants, the switch is receiving frames that are too large. If you see CRC errors, the frame arrived,
And
but
frames
failed
is
the error
PDU.
checking process. That could point to issues like bad cable, duplex mismatch, damaged NIC, bad switch port, incorrect MTU settings, VLAN tagging, or jumbo frame mismatch. So the byte sizes are not just trivia. They help you understand how Ethernet works underneath the commands. For CCNA, the big takeaway is you learn the byte sizes so you can understand Ethernet structure, overhead, minimum maximum frame sizes, and troubleshooting errors. The preamble specifically exists to help the receiver synchronize before reading the actual frame.
Interesting. Sir, what are the syllabus of IT technical support, or what we'll have to do as a syllabus of IT tech? I don't have a syllabus. What are you talking about? What are this? I have no idea. Or what we'll have to do as a I don't know. Oh, are you talking about the knowing the frames and stuff of like why that's important?
1.
I'm not going to listen to all of this.
Simplified answer. Yes. Memorize the important ones, but do not try to memorize every tiny detail equally. For CCNA, you should memorize the core Ethernet frame sizes, especially. The most important exam numbers are Ethernet frame equal to 64 to 1,518 bytes. Payload equal to 46 to 1,500 bytes. MAC address equal to 6 bytes.
So, okay, that's why. That makes sense. And then if we had the... No, it's just kind of going through the same thing again. Troubleshooting, show interface, things like that.
How about the trailer? What's the length of the frame check sequence? It is 4 bytes. This brings the total size, including header and trailer, to 26 bytes. So there's an overview of each field of an Ethernet frame. However, the fields I really want to focus on in this video are the source and destination MAC address fields. I mentioned a little bit about MAC addresses, but let's dig a little deeper. So let's spend a few slides looking into MAC addresses. As I mentioned before, a MAC address is a 6-byte or 48-bit physical address assigned to the device when it is made. This is different than an IP address, which you assign in the CLI when you configure the device. You might also hear the term burned-in address, or BIA, to refer to a MAC address. This is because the address is burned in to the device as it is made. The MAC address is globally unique. No two devices in the world should have the same MAC address.
But you can spoof them.
There are MAC addresses known as locally unique MAC addresses, which don't have to be globally unique throughout the world. However, in almost all cases...
Okay, one thing I've never understood this about MAC addresses. Here, let's Google it real quick. MAC addresses versus IP addresses. Can I get an image? Okay, so this is a MAC address. This is the IPv4 address, right? Okay, never mind. I just defeated my own argument. I was gonna say that, like, if every MAC address is supposed to be unique to the device, how did we not run out of MAC addresses, but we ran out of IP addresses? But it looks like MAC addresses have a significant higher number of combinations that it can be. I knew that. But my thing is that, like, why haven't we run out of MAC addresses? Or is that even a thing that we're even worried about? Probably not.
MAC addresses are globally unique. The first 3 bytes of the MAC address are the OUI, which stands for Organizationally Unique Identifier, and it's assigned to the company making the device. So Cisco, for example, will have various OUIs, which only Cisco can use, and other makers will have their own OUIs, which only they can use.
Okay, that makes sense.
The last 3 bytes, the second half of the address, are unique to the device itself. MAC addresses are written as a series of 12 hexadecimal characters. For those of you who aren't sure what hexadecimal is, let's check it out a little bit. Before explaining hexadecimal,
There's
I want to
another
make sure we
channel
all
called
understand how the
Sunny's
decimal system
Classroom or
works.
something like that.
I don't mean to insult anyone's intelligence. I'm sure you all know how to count. But let's just review the system so we can compare it to hexadecimal.
We might look at that one day too.
The decimal system uses 10 possible digits. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So you start with 0, then 1, 2, 3, 4, 5, 6, 7, 8, and 9. This number 9 here represents 9 ones, or 9 times 1. Then where do you go from here? You have to add another digit, adding a tens column. You probably look at this number and just think 10, but really it means 1 value of 10 and 0 values of 1. Then 11 is 110 and 1 1.
Whoops.
Then you increase the ones column to get 12, 13, 14, 15, 16, 17, 18, and 19. Then you can't increase the ones column anymore, so you add 1 to the tens column to get 20, which is 2 tens and 0 ones. Then 21, 22, etc., all the way to 99. Now both the tens column and the ones column are maxed out. To represent higher numbers, you have to add another column, the hundreds column. 100 means 1 value of 100, 0 values of 10, and 0 values of 1. Then you follow the same process to get 101, 102, etc., all the way to 999. Then once again, you have to add another column to make 1000. So that's how the decimal system works. Let's look at hexadecimal. Well, decimal uses 10 possible digits. Hexadecimal uses 16 possible digits. The first 10 are the same as the decimal system. 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. The other 6 are borrowed from the alphabet, A, B, C, D, E, and F. Although these are the same characters as in the alphabet, they represent numbers here. So hexadecimal A is equivalent to 10 in decimal. B is 11, C is 12, D is 13, E is 14, and F is 15. Here's a chart showing some decimal numbers in black and their hexadecimal equivalents in red. We already saw the hexadecimal numbers up to F.
Okay, I remember studying this when I was taking the Network Plus. So, yes, because then when it gets there, it turns into letters, but it only goes up to F. So it goes 1 through 9, A through F, and then because it just adds a decimal, or it just adds a number in front of it. So it does 0 through 9 again, but with 1 in front of it, and then it does A through F again with 1 in front of it. Yeah, actually, I already have some. If you go to my, I don't know what channel you're watching me on, but if you go to Tyler Lamont, I don't have a lot of videos yet, but I already have some that are here that kind of talk about some of those things. Not all the things that you're talking about, but I talk about some of them and how they work and stuff. That's a song that needs to not be shown anymore. I was originally going to do something different with this channel, and it ended up turning into networking or into IT stuff. But anyway, yeah, go check it out, and there's gonna be more videos on the way with stuff. So yeah.
Which is equal to decimal 15. Notice how the numbers are written after F. This hexadecimal number looks like 10, but it isn't 10. The second column in hexadecimal represents 16. So this is 1 16 and 0 ones. So it's equivalent to decimal 16. This number looks like 11, but really it's 1 16 and 1 1. So it's equivalent to decimal 17. Hexadecimal 1 2 is decimal 18. Hexadecimal 1 3 is decimal 19. Hexadecimal 1 4 is decimal 20.
Right.
Hexadecimal 1 5 is decimal 21. Hexadecimal 1 6 is decimal 22. Hexadecimal 1 7 is decimal 23, etc. Hexadecimal then proceeds 1 8, 1 9, 1A, 1B, 1C, etc. The purpose of all of this is just to give you an introduction to hexadecimal. When we cover Internet Protocol
I've
version
never
6
had
in
it
a later
explained to me
lesson,
like this
we'll go
before.
more
This
in
makes
depth.
a lot of sense.
For now, if you have a general understanding of what hexadecimal is, that's good enough. Let's move on. So here's a simple network, just 3 PCs connected to a switch. Notice the interface names for the switch: F01, F02, and F03.
Okay, so we have MAC address here, MAC address here, MAC address here. They're all connected to the switch. The switch makes an ARP table where it organizes the MAC addresses. And this could be problematic too because it remembers what port that the computer's plugged into. Thank you very much for the subscription, man. I appreciate you. The connection, like this Ethernet cord is connected to a certain port on the switch. And then the ARP table, it's a table that has all the ports and that has all the MAC addresses from it. So then if you switched these two things, you would have to reset the ARP table, or at least reset those two things, those two ports, to make sure the switch knows. Otherwise, you could have collisions.
F means fast Ethernet, so these are 100 megabit per second interfaces. I've also written the MAC address for each PC. You're probably not going to see any MAC addresses like these. I've just simplified them for this demonstration. Notice each MAC address is a series of 12 hexadecimal digits, separated by periods. You may also see periods after every other digit. So for example, PC1's MAC address would be AA.AA.AA.00.00.01. But I tend to write them after every fourth character. The OUI, or Organizationally Unique Identifier, which is the first half of the MAC address, is AAAAAA for each device. So we know that these PCs are all from the same maker. The second half of the MAC address of each device, however, is different for each PC.
That's crazy.
The second
to know
half
that my
identifies the
stream is
device
going
itself.
all the way over
Now, let's
there.
say PC1 wants to send some data to PC2.
That's pretty insane, honestly.
Due to lack of space, I've just written an abbreviated form of the destination and source MAC addresses here. By the way, this kind of frame is called a Unicast frame, a frame destined for a single target, PC2 in this case.
Yeah, there's Unicast, there's Broadcast, and then there's Opencast. I think those are the only 3.
There are other kinds of frames, like broadcast frames, which we'll learn as we go along. But for now,
I literally just named 3 of the 3, and I was like, yeah, I think that's it. And then he names Rawcast, which I've never heard before.
remember this term, Unicast. PC1 sends the frame through its network interface card, which is connected to switch 1, and switch 1 receives the frame. After switch 1 receives the frame, it looks at the source MAC address field of the frame, and then uses...
See, this is what I was talking about. Here's the MAC address, and here's the interface. So that's, I was calling it port interface, which is probably a better term to use. A better term to use is probably interface, not port, because that could be confusing because the word port is used a lot.
Uses that information to learn where PC1 is. As you can see here, it adds the MAC address AAAA.AA00.0001 to its MAC address table, and it associates that MAC address with its F01 interface. This is known as a dynamically learned MAC address, or just dynamic MAC address, because it wasn't manually configured on the switch. The switch learned it itself. Every switch will keep a MAC address table like this, and they fill the MAC address table dynamically by looking at the source MAC address of frames it receives. Since switch 1 received a frame from source MAC address AAAA.AA00.0001 on its F01 interface, it knows that it can reach that MAC address on that interface and adds it to the MAC address table. This is a very important concept, so I'll probably repeat it multiple times. This is how switches dynamically learn where each device on the network is, by looking at the source MAC address of the frame. Now, there is one problem. The destination of the frame is AAAA.AA00.0002, but switch 1 doesn't know where that is. This, by the way, is called an unknown unicast frame.
Okay, so the switch has to build the ARP table, the MAC address table, okay? So even though that this computer is connected to here, it doesn't know that it's connected. It needs to be organized. The best way to, I think the best way to make sure that you understand how switches work is that you have to understand what came before it, which was the bus, where it was literally just one wire that had other wires like coming off of it. And like one person could only send information at a time, basically. There was a few exceptions, but for the most part, that's what it was. It wasn't able to route traffic. It was just like a giant highway that other things were connected to, whereas the switch is more of like a bus station.
A frame for which the switch doesn't have an entry in its MAC address table.
So the switch needs to
Because
now
the switch
find
doesn't know how to reach the destination, it has only one option. That is to flood the frame. Flood means to forward the frame out of all of its interfaces, except the one it received the packet on. So that would look like this.
I'm pretty sure that's also a broadcast. I think it's also called a broadcast. So what it's doing is that it doesn't know where this MAC address is. So it's just sending it out of every single place, every single interface to every single device, and basically being like, hey, is this you? Here's your mail. And then the computer, like computer PC3 is going to say, no, this isn't me. And it's going to completely just drop it. Yes, exactly.
Switch 1 copies the frame and sends it out its F02 and F03 interfaces. It doesn't send it out of its F01 interface, because that's the interface it received the frame on. So what happens next? Well, PC3 ignores the packet because the destination MAC address doesn't match its own MAC address. It simply drops the packet. PC2, however, receives the packet and then processes it normally up the OSI stack. However, unless PC2 sends a reply of some sort, it stops there. Switch 1 never receives a packet from PC2, so it can't learn PC2's MAC address and use it to populate the MAC address table. So let's say PC1 sends another frame to PC2. Once again, it is received by Switch 1, and it already knows PC1's MAC address, so it doesn't have to add it to the MAC address table again. However, it still doesn't know where PC2 is, so it once again floods the frame. PC3 drops the frame, and PC2 receives it and processes it normally. Now let's say PC2 then wants to send some data to PC1, maybe a reply to what PC1 sent to PC2. Notice the destination and source addresses of the frame are reversed. PC2 sends the frame out of its network interface, and Switch 1 receives it.
And
Switch 1 looks at the source MAC address of the frame,
because switches only record
associating it
addresses
with
on
the
their
F02
table
interface.
that are sending.
This time, however, it doesn't flood the
receiving.
frame. This is known as a known unicast frame, because the destination is already in its MAC address table.
Okay.
Whereas unknown unicast frames are flooded, known unicast frames are simply forwarded to the destination like this. And PC1 then processes the frame up the OSI stack through the de-encapsulation process, which we learned about in day 3's video.
I know this goes beyond the scope of what we're talking about with MAC addresses, but it just kind of makes me think like the overall scope of everything that works. Like if I wanted to talk to someone in Japan, I have a bunch of hops to a bunch of different routers. Okay, that makes sense. But my information that I'm trying to send, like my email or whatever that I'm trying to send, is marked with the destination of where it needs to go and the device that it needs to go to. So how does that work with, like, I'm just like formulating the complexity of it that we have now. Cause like if I wanted to send an email from this computer right here to someone in Japan, I'm not actually sending it to a device. I'm sending it to a cloud. Like I'm sending it to Gmail or something like that. Right. And then Gmail's got to forward it. And then the person probably has their Gmail on multiple devices. So it just kind of like, I'm just seeing how it all can be complex. And then let's say that the person pulls that email up on their phone while they're in their company's building. Well, now they're on an access point. Now they're in the company's network. Now we're dealing with NAT or dynamic NAT or PAT or, you know, like I'm just starting to see how it all kind of like stacks and how complicated our daily things are. Like that's just so insane to me.
One more point about these dynamic MAC addresses. On Cisco switches, these MAC addresses are removed from the MAC address table after 5 minutes of inactivity. So if PC1 didn't send any traffic for over 5 minutes, Switch 1 would remove the MAC address to clean out the MAC address table. Of course, if PC1 sent traffic again, Switch 1 would dynamically learn its MAC address again. Let's look at another example, this time with 2 switches. Notice the MAC address table of each switch. Currently, they are empty, so once again, we will see the process of MAC address learning and flooding. So, PC1 wants to send some information to PC3. The source MAC address of the packet is AAAA.AA00.0001, and the destination is AAAA.AA00.0003. So PC1 sends the frame out of its network interface, and it arrives at switch 1. Switch 1 learns PC1's MAC address from the source address field of the frame, and associates it with the interface
Okay, never mind.
on which it was received, F01. I'll just say once more, I'm only writing a short version of the MAC address due to the lack of space here. Really, the frame and the MAC address table would include the whole MAC address, of course. Once again, a MAC address learned in this way is called a dynamically learned MAC address, or more often, a dynamic MAC address. Now, switch 1 has learned that PC1 can be reached via its F01 interface, but it still doesn't know where PC3 is. Do you remember the name for this kind of frame? It's called an unknown unicast frame. And what does a switch do with an unknown unicast frame?
It just blasts
It floods it out all of its ports, except the one it was received on. In this case, it will flood the frame out of F02 and F03, but not F01, because it received the frame on F01. PC2 drops the frame because the destination MAC address doesn't match its own MAC address. Now, what will switch 2 do? Well, the exact same rules apply. Just like switch 1 did, it uses the source MAC address field of the frame to dynamically learn PC1's MAC address and the interface it can use to reach PC1. Note that, unlike on switch 1, PC1 isn't actually directly connected to the interface switch 2 enters in its own MAC address table. However, this is the interface which switch 2 will use.
So what you're asking about, okay, but sir, in the first scenario of MAC address, what about PC3 MAC address, which is not? So you're talking about this one that was over here. So, if I'm understanding your question correctly, what would have happened if this would have been going to PC3, the process would have been exactly the same. That would have had the MAC address of 003, and then it would have flooded it, and it would have gone to PC2. PC2 would have dropped it, and then it would have gone to PC3. And if PC3 would have tried to respond back, then it would have gone to the table. So that is what's going on. It doesn't have to have, the switch doesn't have to have every single MAC address in its address table in order for it to flood. All it has to do is be connected. As long as it's connected to the switch, it'll flood it.
Interface it can use to reach PC1.
And that's exactly what's happening here, is that it sent something, it flooded it, so it went to PC2, it went to PC3. Now, if PC2 wanted to talk to PC1, it would go here. And since PC1 is already in the address table, it would just, when it flooded, it would just go here and then bounce back. Well, I don't want to say the word bounce back, but it would forward it to the correct place. If PC2 wanted to talk to PC3, PC3 is already here. If PC2 wanted to talk to PC4, PC4 is not here. If PC2 sent a packet or information, it would go to switch 1. Switch 1 would then notate or label PC2's MAC address in the table. This wouldn't know where PC4 is at. So then it would just flood it to all of its ports. And this kind of goes back to what I was talking about, like the complexity of it. Because this switch, because you can kind of see how it can be strange. Like, how would this switch know the MAC address of PC4? Because PC4 is plugged into the switch 2. Switch 1 would only know the switch, or would only know the MAC address of the switch 2. You're correct. That does seem very problematic. That does seem very strange. But it knows that it has to get to this MAC address first to get to this MAC address. And now we're starting to talk about different hops and things like that. Hops are usually in terms of like, what's the word? From router to router, but this isn't.
Note that, unlike on switch 1, PC1 isn't actually directly connected to the interface switch 2 enters in its own MAC address table. However, this is the interface which switch 2 will use to reach PC1. That's the meaning of the interface in the MAC address table. It doesn't mean the device is directly connected to this interface. Now, switch 2 received a unicast frame. That is a frame destined for a single device. But it doesn't know how to reach that device, because it's not in its MAC address table. One last time, what is this kind of frame called? It's an unknown unicast frame. And what does the switch do with it? It floods it out all interfaces, except the one it was received on. So, which interfaces will it send the frame out of? Well, it received the frame on F03, so it won't be flooded out of that interface, but it will be sent out of all other interfaces, F01 and F02 in this case. PC4 drops the frame because the destination MAC address doesn't match its own. PC3, however, receives the frame, as the destination MAC address matches its own MAC address. Let's say that PC3 is going to send a reply back to PC1. Notice the destination and source MAC address fields of the frame are reversed. PC3 sends the frame out of its network interface, and it is received by switch 2. Switch 2 learns PC3's MAC address and enters the MAC address and the corresponding interface in its MAC address table. Just so we're clear, the switch uses the source MAC address field to fill its MAC address table because if it receives a frame from that source on the interface, it knows that it can reach that MAC address via that interface. So let's continue. Switch 2 already has an entry for the destination MAC address, AAAA.AA00.0001 in its MAC address table, so there is no need to flood the frame. Instead, it is forwarded normally out of the corresponding interface in the MAC address table, which is F03.
So it fills this out with the source MAC address. Okay. That kind of breaks my brain a little bit with like jumping between two different switches.
3. The frame is received by switch 1, which adds an entry for PC3's MAC address in its MAC address table with the interface F03, since that's where it received the frame.
Yes.
Finally, since switch 1 already has an entry for the destination MAC address in its own MAC address table.
Now, look, so I'm not 100. I know that a hop is from router to router. I don't know if the word hops are also used in terms of switch to switch or switch to router. It might. We can look that up in a second to make sure that we're using the correct terminology.
Switch 1 forwards the frame out of the corresponding interface, and it reaches its destination, PC1.
Okay, now hold on. Now this is where I'm getting confused, and we might use ChatbotGPT to figure this out. So PC3 wanted to send something to PC1. Switch 2's MAC address table says that PC1's MAC is 0001 in interface 3. So in order to get the packet, the email, whatever it is, the information from here to here, this knows that the switch knows that it's looking for PC1 with the MAC address of this, and that is going to come out of this port. So then when it comes here, it's looking for this MAC address, and it knows that it's looking for this port, this interface. I need to say interface, not port. Okay. It's not as complicated as I thought it was. It's actually fairly simple. Let's keep going.
PC3's MAC address in its MAC address table. Which field of an Ethernet frame provides receiver clock synchronization? A. Preamble. B. SFD. C. Type.
I think it's preamble.
Or D. FCS. Pause the video to think about your answer.
Which field of Ethernet frame provides receiver clock synchronization?
The answer is A. Preamble.
Yeah, preamble.
Let's check.
Let's go.
The SFD, or start frame delimiter, signifies the end of the preamble. It is not used to provide receiver clock synchronization. So B, SFD, is incorrect. The type field indicates the type of packet encapsulated within the frame. So C, type, is incorrect. The FCS, or frame check sequence, is used to detect errors that occurred during transmission. So D, FCS, is incorrect. The preamble is a series of ones and zeros, or 7 bytes of 10101010, which allows the receiving device to synchronize its receive clock. So A, preamble, is the correct answer. Let's go to question 2. How long is the physical address of a network device? A, 32 bytes. B, 32 bits. C, 48 bytes. Or D, 48 bits.
What do we think it is, chat? Remember, bytes is 8 bits. 1 byte is 8 bits. I'm pretty sure. I think it's C. I think it's 48 bytes.
Pause the video to think about your answer. The answer is D, 48 bits.
Dang.
Remember, a byte is equal to 8 bits, so 48 bytes is equal to 384 bits. The MAC address, which is an address assigned to the physical device, is 48 bits, not bytes long. By the way, an IP address...
That also strengthens my argument of, like, how come we haven't run out of MAC addresses yet? If it's only 48 bits. Yeah.
Which we will learn about soon, is 32 bits in length. Let's go to question 3. What is the OUI of this MAC address? E8BA 70112874. A. E8BA.
I don't remember
B.
doing this.
E8BA.70.
Did we talk about
C.
this?
7011. Or D. E8BA.
Hold on. OUI? I'm about to... MAC address is this device. Second half identifier. So is it 7011?
7011. Pause the video to think about your answer. The answer is B, E8BA.70. The OUI, Organizationally Unique Identifier, is the first half, or 24 bits, of a MAC address. It is a unique value assigned to the maker of the device. The first half of this MAC address is E8BA.7.
I do not remember... What time stamp? We're at 34. I do not remember him talking about this.
The OUI, or Organizationally Unique Identifier, which is the first half of the MAC address, is AAAAAA for each device. So we know that these PCs are all from the same maker.
Oh, that's what it is. Because he talked about how different ones, different like devices from proprietary things, like they all have their own unique one. So that's how you know if it's on the right device or not. Okay, interesting. All right, where are we at? We're here.
Which field of an Ethernet frame does a switch use to populate its MAC address table? A, preamble. B, length. C, source MAC address.
The source MAC
or
address.
D,
C.
destination MAC address. Pause the video to think about your answer. The answer is C, source MAC address. Let's check. The preamble is a series of ones and zeros, 7 bytes of 10101010, which allows the receiving device to synchronize its receive clock. It is not used to populate the MAC address table, so A, preamble, is incorrect. The length field indicates the length of the encapsulated packet. It is not used to populate the MAC address table, so B, length, is incorrect. Although this field does specify a MAC address, it does not help the switch populate its MAC address table, so D, destination MAC address, is incorrect. A switch uses the source MAC address field to populate its MAC address table. It associates the source MAC address with the interface on which the frame was received. This allows the switch to learn how to reach other devices on the network. So C, source MAC address, is the correct answer. Let's go to question 5. What kind of frame does a switch flood out of all interfaces except the one it was received on? A, unknown unicast. B, known unicast.
Unknown.
Or C, allcast. Pause the video to think about your answer.
We didn't talk about all casts.
The answer is A, unknown unicast. Let's check. A known unicast frame is a frame for which the destination MAC address is already in the switch's MAC address table. Since it already knows how to reach the destination, there is no need to flood the frame. So B, known unicast, is incorrect. Allcast is not a type of Ethernet frame, so C, allcast, is incorrect. An unknown unicast frame is a frame destined for a single host. However, the switch doesn't know how to reach the destination, so it floods the frame out of all interfaces except the one it was received on. So A, unknown unicast, is the correct answer. As usual, there are additional supplementary materials to help you understand and remember what you studied. There is a pre-made deck of Anki flashcards to help you review. Check the link in the description. There will be a packet tracer lab, but I'll leave that for after part 2 of Ethernet LAN switching.
Yeah, after part 2.
So there won't be a practice lab for this video specifically.
That's fine.
Good luck with your studies. Thank you for watching. Please subscribe
Yeah,
to the channel.
dude, he
like
is
the video,
absolutely
leave a comment,
amazing.
and
You
share the
should
video with anyone
definitely
else studying for the
subscribe to his
CCNA.
channel.
If you want to leave a tip, check the links in the description.
Yeah.
I'm also a Brave verified publisher and accept BAT or basic attention token tips via the Brave browser. That's
Maybe
all for now.
maybe we'll donate to him one day. Maybe after like I take my test or something. Okay. Where is Anki? Boom, the Anki flashcards. Okay. We're going to look at them. We're going to try them. Number 5, day 5. There we go. There's only 38 of them. Okay, hexadecimal C equals decimal 10 would be A, right? Yeah, 10 it would be A. No. Yeah, A, B, C, D. Is it D? What? Why did I say D? That was dumb. Okay, we're going to come back to that. Because A would be 10. B would be 11. C would be 12. Okay. I had it right in my head. I just didn't say it right. Okay, we'll come back to that one. Okay, hexadecimal B. Oh my gosh. Okay, isn't that just gonna be 11? Yes. A MAC address learned by a switch without manual configuration is called isn't it called dynamic through the source? Dynamic MAC address. Yep. Ethernet header source is how many bytes? Isn't it 6? Let's go. Okay. What does MAC address or MAC stand for? Oh, crap. I'm drawing a blank. I like literally the only thing that's in my brain right now is switches. I never turned on my light. I didn't realize how dark it was. There we go. That like helps out a whole lot. Media access control. Hey, you are correct, sir. We're going to do that one again, though. Okay, by default, a dynamic MAC address will be removed from the MAC address table after time or inactivity. Oh, a dynamic MAC address. Yes. 5 minutes. Whoa. I didn't know I could do that. Hexadecimal C is 12. That's not something you really need to... Yeah, it's not something you really need to memorize. It's just something that you just have to understand how it works. I'll go a little bit slower so that way chat can catch up. Okay. Ethernet head preamble. How many bits is that? And I'll check to make sure that the latency should be... Yeah, low latency. That's also ultra low latency. So it doesn't matter where you're watching or what channel should be there. So I'll give a few seconds.
7 bits.
Yep, 7 bits. What does the MAC address stand for? Stands for media access point. We already did that one. Ethernet header destination. That's going to be, I think that's 6 as well. What do we think? 6? Going once? Going twice? 6. What is the only field in the Ethernet trailer? The FSC? I believe that's what it is, the FSC. Yes, FCS, frame check sequence. Yeah, it checks for broken frames and things like that. What is the bit pattern of 1 byte in the Ethernet preamble? Isn't it 1010100? Oh, so close. 101010010. I thought it was 7. 1, 2, 3, 4, 5, 6, 7, 8. Oh, it's 8. Okay, I might need to relook at that again. Hexadecimal A is going to be, was that 10? There we go. What is the bit pattern of the Ethernet SFD? SFD. What is the bit pattern of the Ethernet SFD? Is it 01010111? I feel like that's not right. Oh, I got the 1 correct. 10101011. Nice. I love how that. I love how my TTS speaks that. Says that. What is the Ethernet type value of IPv6 in hexadecimals? What? I don't understand. What is the Ethernet type value of IPv6 in hexadecimals? I don't know it. What is? Hold on. See what it says real quick. Ethernet type value of IPv6 is, yeah, it's the same thing. It just said it. Okay, cool. This is called the Ethernet type value. It tells the receiving device the data inside the Ethernet frame is IPv6 packet. So the answer is, I just don't remember. I do actually know. I do kind of remember going over this in the video. Analogy. Think of the Ethernet frame like a shipping box. On the outside of the box, there is a label that says what is inside. IPv4 is 800. ARP message is 0806. 86DD is interesting. So where is this? Where? Here it is. Real world. Imagine your computer sends IPv6 traffic to another device on the network before IPv6 packets can travel across the internet. It gets wrapped inside the internet frame. Okay, that frame might look like this. Here's the MAC address. Here's the source MAC address. Here's the Ethernet type. Got it. Okay, I understand. So it's in the frame. Here's the payload. That's the actual packet. So can we get a example here? So source right there. That's where it's at. No, type. It's right there. That's the internet Ethernet type. And then it's the packet. Okay. I understand. Okay, we'll come back to that because I need to memorize that 86DD. I wonder what the significance is for why it's 86DD, but that's for another day. What does FCS in the Ethernet frame stand for? Man, I cannot remember. Frame check sequence. I knew that. I remember that. Okay, we'll come back to it. What does a switch do with an unknown unicast frame? It blasts it. It floods it out all ports except the one that it received it on. So all interfaces. Okay. What kind of algorithm does the Ethernet FCS use? What kind of algorithm does it use? I have no idea. I don't remember this either. The Ethernet FCS uses a CRC. Oh, I do remember CRC, but I didn't know it was called this redundancy check. Actually, maybe I did. I kind of remember that now. Ethernet FCS uses CRC32. Its job is to detect whether the Ethernet frame was damaged or changed while traveling across the internet. Like, think of it like a receipt at the bottom of the grocery receipt. About 3 apples, bread, blah, blah. When you get home, you add up the items and check and realize that it equals 12. Okay, yada, yada, yada. More in-depth answer. Dynamic MAC, source address, type, length, data, FCS. Okay, and FCS uses the redundancy check.
One. Simplified answer. The Ethernet FCs uses a CRC algorithm. More specifically, Ethernet FCS uses CRC32. CRC stands for Cyclic Redundancy Check. 4. Real-world scenario. You are troubleshooting a switch port and run. Show interfaces. You see something like CRC errors input error as FCS errors. That usually means the switch received Ethernet frames, but the CRC calculation failed. In real life, that could point to bad Ethernet cable, damaged connector, bad switch port, bad
Oh,
NIC,
because it dropped
electrical
packets,
interference,
or it
duplex
dropped
mismatch,
information.
physical layer issue. So the answer to the question is Ethernet FCS uses CRC32, a cyclic redundancy check algorithm used to detect frame corruption.
Okay, I understand now. Hexadecimal B, I think that's 12. No, 11. Okay, I'm good on those. I understand that. The MAC address is written as blank hexadecimal characters. 4, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Understood. A MAC address learned by a switch without manual configuration is called dynamic MAC addressing. Yep. What does SFD in an Ethernet header stand for? What does SFD in an Ethernet header stand for? Where is that? This is the preamble, that's the destination, that's the source, whether or not it's like a MAC address or IPv4, IPv6. This is where it's going, where it's coming from. Man, I cannot remember. Start frame. What? Delimiter? What is the point of the SFD? What is the point of the SFD? Probably not going to read through all of it. I just want a simple answer. The SFD tells the receiving device the preamble is over. Oh! The real Ethernet frame starts now. And that's why the preamble is not considered a part of the Ethernet header. And then the SFD is like, hey, it's done. This is what's going on. Okay, so the preamble is 7 bytes. And then the SFD is 1 byte. And then total of 8 bytes. The exact starting point of the actual Ethernet frame. Interesting. Yeah, so it says good to go. Let's say your PC sends an Ethernet frame to a switch. Before the switch can read the destination MAC address, it needs to lock into the incoming signal. So the PC sends preamble, SFD, destination MAC address, source MAC address, type, data, and then FCS. This is what's difficult. This one's FCS and this is SFD. I hate acronyms. I hate them. I understand why they're important, but I hate them. Then it sees the SFD and knows, okay, the very next bit is the destination MAC address. Ethernet header shows 6. No, 7. Wait. 6. Yep. Hexadecimal C, that's a 12. A MAC address is written as a 12 hexadecimal character. Nice. Okay, by default, a dynamic MAC address will be removed from the MAC address after time of inactivity. 5 minutes. What does FCS in an Ethernet frame stand for? We just went over that. No. This is the end. SFD shows that the preamble is over and that the destination MAC address is coming up. FCS uses CDC protocol to determine if there's anything broken. What does it stand for? I know what it is. Frame check sequence. Because the UDP we're in is a frame. Yeah, No, or is it called UPI? Crap, man. There's so many acronyms. What does MAC address stand for? Media access control. Ethernet header destination 6. What is the Ethernet type value of IPv6? 86DD. Okay, this is gonna be really weird, but the way I'm memorizing that it's 86, and I have like this literally makes no sense, but it makes sense in my brain. It's because of the x86 file that's on your computer. Where you have like the 32 and the 64 and then the 86. I don't know why I have that connected, but I do. Might not be a good study material, but that's what I have. Ethernet header preamble is 7 bytes. What is the bit pattern of 1 byte in the Ethernet preamble? 10101010. Yep. 246 because it's 6. Because that's the 2, 3, 4. Okay, I'm not gonna worry about that because this says 7. This is obviously 6. 2, 4, 6. No, this is 8. This is obviously 8. I'm not gonna worry about it. I'll figure that out later. That's a future me problem. What is the only field in an Ethernet trailer? What is the only field in an Ethernet trailer? Oh, the SFC. It's the one that checks. FCS. Frame check sequence. Man, I gotta really hone that one in. Hexadecimal A, isn't that 10? What kind of algorithm does the Ethernet FCS use? It uses CDC. We just talked about that. Either here or up there. Yep, the redundancy check. What is the bit pattern of the Ethernet SFD? 10101001. No. 101010 10101011. Yes. SFD is the one that signifies that the preamble is over and that the destination is about to happen. I don't know what SFD stands for, but I know what it does. Okay. What does a switch do with an unknown unicast? It floods. Floods it at all ports. Which I've tried to say the word interface and not the word port. How long is the MAC address? 12 hexadecimals. 12 or 12. It's in 12 groupings. Well, it's in 6 groupings, but there's 12 in each. There's 2 in each.
One from India, bro. Red heart.
Hey, thanks, dog. See right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So they're in groupings of 2. So that means that there's 6 groupings and for a total of 12. Ethernet header SFD is one byte. Yep. The value of blank is less than the type length field indicates length. The value of blank is less than the type length. So talking about the SFD? Bro, what? What is that? What is this? A value of blank or less. I do not remember him talking about that at all. I do not. We're gonna come back to it. Things are being a little laggy right now, probably because my thread's getting really long. What does SFD and the Ethernet header stand for? We'll come back to that one. All right, talk to me. Whoa, come on, dude. This is why I have AI to read, so that way I don't have to. Man, my computer is on the struggle bus. Bro. Okay, whatever.
One. Simplified answer. That question is asking, in the Ethernet type length field, how does the device know whether the number means length or protocol type? The answer is, if the value is 1500 or less, it means length. Why? Because the largest normal Ethernet payload is 1500 bytes. So if the type length field says 1500 or less, the device says, this number is describing how many bytes of data are in the payload. But if the value is larger, it usually means this number is identifying the protocol inside the frame. For example, value meaning 150 or less length 0, value meaning 1 fo0x 80 IPv. Think of the type length field like a label on a box. Sometimes the label tells you how heavy the box is, 100 pounds. Other times, the label tells you what is inside the box, books. 3. More in-depth answer. In an Ethernet frame, there's a 2-byte field after the source MAC address, destination MAC or source MAC, or type length or data or FCS. That field can be used in 2 different ways. Option 1, length field. If the value is 1500 decimal or less, it represents the size of the payload. Example, type length field equal to 100. That means the payload is 100 bytes long. This is associated with older IEEE 800 and 2.3 style framing, where the field was used as a length value. Option 2, type field ether type. If the value is larger, it usually identifies the protocol inside the frame. Examples, ether type decimal value protocol, ether type decimal value. Important CCNA detail.
Okay.
There is a gap between 1500 and 1536. Values 1500 or less, mean length. Values 1500, 06, 0600.
Interesting.
Values and 1535 are generally not used for normal Ethernet type length interpretation. The reason the answer is because 1500 bytes is the maximum normal Ethernet payload size. So any value from 0 to 1500 could reasonably be a payload length. 4.
So here we go.
Real world example. Wireshark captures an Ethernet frame. You see this. Destination MAC, FFFFFF source MAC, AABCCD all X806. Because 06 is greater than 1500, Wireshark treats it as an ether type. So it says protocol ARP. Now imagine the field showed 100. Because 100 is less than 1500, The device treats it as a length value, meaning payload length equal to 100 bytes. 1,500 bytes,
And this
or less
goes back
equal
to
to
the
length.
type.
Greater values, 1,536 or
So that's the
600
length,
and
that's
above,
the type, Ethernet
usually equal to
type.
type. For CCNA, memorize this. Less than or equal to 1,500 equal to length greater than or equal to 1,536. 800
Okay.
equal. 800 equal to ARP0 times 0x.
That was weird. Okay, what does SFD stand for? Do not remember. Not even a little bit. I know what it is. Start frame delimiter. Oh, because it tells you when the preamble's over. Start frame. Okay, the MAC address is written as blank hexadecimal characters. 12? Or is it talking about the groupings, which is 6? Okay, 12. How long is a MAC address? 48. Nailed it. Hexadecimal, that would be 14, 13, 13. Yes. All right. Ethernet trailer FCS is how many bytes? Is it 6? It's 4. Which field of an Ethernet header is used for synchronization? Let's think about this. The destination, the preamble. Okay. A switch will flood in blank Unicast, an unknown. A value of blank is greater in the type length field indicates type. Oh, we just did this. Anything greater than 1536. Yeah. Which field of Ethernet header marks the end of the preamble? It's the one I'm always getting mixed up. It's the limiter. The relimiter. FC R? No. FCS? SFD. Delimiter. Hexadecimal F. Oh, crap. So, A's 10. A, B, C, D, E, F. 15. Yes.
All the best, buddy.
Thanks, dog. Which field of an Ethernet header is used for synchronization? Oh, that's the preamble. Nice. Let's do it again. Okay. What does FCS in the Ethernet frame?
And revising now.
Nice. It's good. What are you are like you just finished the Anki cards? Is that what it is?
Exam in July 24th.
Ooh, nice. I'm aiming to get mine probably in September. I might take it earlier, but that's my projected forecast. What does FCS in the Ethernet frame stand for? Oh my gosh, dude. I struggle with these. I hate acronyms. FCS. That's the one that's in the end. It's 4 bytes. Frame checker something. Frame checker something. Frame check sequence. It was close. What is the Ethernet type value of IPv6 in hexadecimals? 86DD. Yep. And I don't know how that DD works with this. Anything greater than 1500 or less than 1500 or equal to or less than 1500 is length. Greater than or equal to 1536 is type.
Doable, but the real brain pain is during revision LOL because you gotta remember concept of 40 different topics.
Yeah. I don't know. I'm pretty good at like memorizing things because I go in depth with it. So I'm not gonna say I'm not worried, but because it's definitely gonna be difficult. But I feel strongly about my. I feel strongly with my strategy of studying. I'll say. So we have 0800, 0806, and then 86DD. I want to know what those DDs mean. But that's for another day. What kind of algorithm does the Ethernet FCS use? It uses CDC. Yes. It's a redundancy check because this is something check sequence. We just did it. Frame check sequence. Ethernet header SFD, which signifies the end of the preamble and that the next frame.
Strategy. YT randomly recommended your channel.
So my strategy is very simple. My strategy when I study anything is that reading a book about something will give you knowledge of that thing. Like if I read a book about the beach, I will learn a lot about the beach. But if I go to the beach, I will learn more and retain more information on the beach. This is where a lot of people will stop because they'll be like, oh, well, hands-on information, hands-on things are like way better, right? And then they won't read the book. But if I read a book about the beach and then go to my local beach, I will then learn and have a deeper understanding of how things function. But because I had my hands on it, but because I read the book about things that I don't have access to, maybe I only have access to Florida Beach, but I don't have access to the beach off of Madagascar or something. I don't know. You know what I'm saying? So I'm reading a book about the beach that has information that I don't have the ability to touch, and then I'm physically going somewhere and touching the stuff. And that's actually how my prompt for chatbot GPT works. See if I can show you my original prompt. So my original prompt is that this thread is going to be solely for studying CCNA, and I gave it Jeremy Tech Labs video so that way it knew what I was doing. And then I said, anytime I ask a question, I want you, or how something works, I want you to answer it and give me a simple answer for easy recognition.
So you are going to buy second equipment after preparation.
Already, dog. Buddy, I'm ready. Let's go. I'm networking my entire house. Like, I got 1,000 foot of wire. Yeah. So, yeah, I'm learning the stuff, and then I'm actually trying to physically do it. Now, again, there are things that I can only do in my house that are only in my house. Like there are certain protocols and certain things that I won't ever be able to replicate. That's why I have the packet tracers and stuff like that. So I'm reading the books, I'm doing the things, and then I'm physically trying to do the things that are here. And that's why I always want a simple answer, so that way I can just get it in my head. And then I want an analogy, because if you can understand how it relates to something else that you already understand, then you're going to have a better likelihood of not just remembering it, but actually understanding it. And then giving me a more in-depth answer. So no more bullshit on like, analogies, but like what is the actual nitty gritty? What's the actual technical terms? And then a real world scenario, an example of what this actually looks like. And that is my method. That is how I study. That's and it works for me. There's probably other ways out there that are better, but that seems to be the absolute foolproof plan, I would say. And if you look, when I ask ChatGPT things, that's exactly what it does. It gives me the more in-depth answer, gives me a real-world example, and when it does that, it makes a lot of sense. So the Ethernet header, SFD, is going to be how many bits? I think it's 4. It's 4, right? Oh, no, it's fine. Oh, secondhand equipment. I do have some secondhand equipment. Yeah, I mean, I'm not going to buy like brand new stuff. Like, I'm not going to buy a brand new switch, a Cisco switch, just for my house. That's absolutely insane. I just have like a little, what is it, a TP? Like, it's just, it's like 8 or 10 ports. But I have like a little server over here that I use putty and stuff. Yeah. The SFD is 1. It is 1 because it comes after the preamble. You were correct. Hey, look, there we go. How long is the MAC address? 6 groupings of 12. Yep. I'm getting the 12 and the 6 mixed up. A value of blank or less than is the type length. That would be 1500. A blank frame is a frame for a single target. Uni? Yeah. Which frame of an Ethernet frame, or which field of the Ethernet frame does a switch use to learn to populate? Oh, the source. Source MAC address. The first 3 bytes of a MAC address are the... Oh, crap. We just went over this because when we went over it, I was like, I don't know. Like, I don't remember him talking about this. And then I went and I looked it up. It's like, it basically says what it is, like if it's a Cisco switch or something like that, like because there's like certain reserved things. A OUI, organizational unique identifier. There it is. And see, if you just saw like right there, I just went through my method. I couldn't remember this, so I went back and I started with a simplistic answer, and then I made an analogy. And then where I stopped was number 3, which was a more in-depth answer, which is what it was wanting. And then I gave what the real-world example of it would have been. Well, I guess I didn't really give that, but I had it in my brain. I was visualizing it. So I checked 3 of these 4 things. And now when I come back the next 2 times, 3 times, I'm going to remember it. And I'm not just going to remember it. I'm going to understand it and know what it is and be able to explain it. Remember, if you can't explain something, you don't actually know how it works. How long is the MAC address in bits? 12. No, 48. A's 10. Yeah, we'll go over that too. Yeah. I felt guilty for not knowing how to do that for a really long time. It's way easier than you think it is. And I know what you feel like because you're like, well, I don't care if it's easy or not because I've never done it. What I would suggest for you to do is this it? No. I would suggest that you go to True Cable and you buy yourself one of these. They're a little expensive, but they're like really, really good. It helps you cut the wire, do all the stuff. And then I would just go to Walmart and I would just buy a cheap Ethernet cable, like 6 foot, 3 foot, whatever. And I would just cut that bitch. Yeah, it's a crimping tool. Exactly. And I would just go to Walmart and buy like a little poo-poo, little piece of shit like Ethernet cable, and I would just cut that bitch, and I would strip it, and I would just like try to terminate it. You don't need 1,000 foot of wire. The reason I have 1,000 foot of wire is because I'm running it throughout my entire house. What did I say this was? I think it's 13. Yeah. What does SFD in the Ethernet header stand for? This comes after the preamble. It's 1 byte. It signifies that the destination is coming up. Delimiter. That's what the D stands for. D stands for delimiter. Because it's telling you that the preamble is done.
Got it. So I will delay my guiltiness.
Yeah. I know that this is delimiter. And I know where this is. I want to say signal, but I don't think it's signal. And I want to say frame, but I don't think it's frame. Start frame delimiter. Because it starts it. Okay. Because the preamble is not considered, and so is the SFD. These are not considered a part of the header. Even though they are in the header. Okay. A switch will flood a blank unicast frame. Unknown. Hexadecimal F. So A, B, C, D, E, F, 15. The concept of 0 is crazy. Which field of an Ethernet header marks the end of the preamble? The SFZ, the FSC, the SFD, the start frame delimiter.
So after finishing Jeremy full course, I recommend you follow this.
If you try to send a link, I might have had it blocked. If you tell me the name of the channel, I'll look it up. But I think I have links blocked, just so you know. A value of blank or greater in the type length field indicates type. 1586 or 36? 36. 1836. Wait. Hold on. This is dumb. Just stay with me. Wait. When did black people get the right to vote? That's crazy. Hold on. Oh, okay. I thought 1536 is when Beethoven died. But I knew better. I was just trying to connect it to something that was unrelated. Don't worry about that. That was just me being dumb. Okay. But 1536, there's something interesting that happened in 1530s that I don't remember. It doesn't matter. Okay. Ethernet.
Flashcards, practice subnetting, take exam or any dump questions, then redo all labs, then take the exam. This is my plan. I use Jeremy's just like you.
Yeah, dude, that sounds like a really good plan. After I hit, I have it written down somewhere in my study plan that after I hit so many of his days, I think it might be like 10 or 15, I'm going to go through and just have a stream where all I do is go through his flashcards and all I do is go through the packet tracers up until that point. So yeah, that's a really good it's a really good method right there. Ethernet trailer FCS. Oh, I don't want to cheat. FCS is 4 bytes. But what I really need to know is the frame checker sequence. Which field of the Ethernet header is used in the synchronization? Preamble. What is the Ethernet type value of the IPv4? 0806? No, 0800.
Flashcards is very hard cause it's like 2,000 cards totally and I can't do more than 200 for a day.
What I would do if I were you is so one, you already figured out how many you can do, right? So most of the cards or most of the days are grouped with about 20 or so, right? I think some might have a little bit more than that. I would do a randomizer and not randomize all the cards, but randomize the days, randomize the groupings. So if you know that your limit is about 200 a day, then figure out how many of his days equal 200, and then randomly group them, and then make a study plan through that. That's what I would do. What is the Ethernet type? Oh, it is 0800. What are the 5 fields of the Ethernet header? The preamble, the SF, no. It's the thing that tells it that that's going to stop. It's not the checker. I can talk more into it. How about that? It's because it's a dynamic microphone, so it only picks up things right here. So if I go over here, then you can't really hear it. Because basically it's already turned up as high as it can go. Oh, but I can turn it up a little bit in OBS. How about that? There we go. I'll max it. All right, so it's the preamble. SCF. No, there's no C. It's the delimiter. F.
Stay close. It's loud.
If I stay close, it's too loud. Okay. Delimiter. So it's
Now better.
F. SFD. So it's the preamble, SFD, the destination, the type, and then the checker. Preamble, destination. Oh, fuck. I forgot the source. SFD. Okay. Source, type. Oh, that's the trailer. That wasn't a part of the question. A blank frame is a frame disdained from a single target. Uni? Yeah, Unicast. Ethernet header type length equals 0 to 1500. That is not what the question was. Type length is this. However, that's not what it wanted. It wanted to know the bit.
Where are you from?
I'm in Texas. Good old Texas. Which field of an Ethernet frame does a switch use to learn and populate a MAC address? The source. I'm almost done. Okay. A, B, C, D.
Home of Texas Instruments.
Yeah, I guess Texas Instruments, like musical instruments or instruments like for like tools. I didn't know that Texas made instruments. Well, I mean, there's ProMark. I don't know if they're in Houston anymore. Anyway, what was I doing? A, B, C, D, E is 14. The first 3 bytes of a MAC address are the... Oh, crap. I know this. I can do this. It's... It tells us where it's from. It tells us what it is. It's the OUI, the Organizational Unique Identifier. What is another name for a MAC address? I don't know. Is it wanting to know what MAC address stands for? Oh, a burned in address. I did know that. The first blank bytes of a MAC address are the OUI. The first blank bytes. The preamble?
Texas Instruments is an interesting company. They make amplifier chips. DLP for projectors.
Wow. I had no idea. Whoa. Huh. Wow, that's dope. I had no idea this was in Texas. I mean, I'm not surprised. Texas is the greatest country in the face of the planet. But that's pretty cool. I'm going to save that for later. I'm going to look more into that. The first blank bytes MAC address are is it talking about like the preamble, the first 7? The first 3 of the 7. Okay, that makes sense now. What is the Ethernet type value for IPv4 and hexadecimal? What is the Ethernet type? Isn't that 0800? A, B, C, D, E, 14. I'm not going to memorize that. That's stupid. What is the header length type? Equal in bits. 2. What are the 5 fields of the Ethernet header? The preamble. This is one I struggled with earlier. SFD. The destination and the type. Source and type. Dang it. Because it's destination then source. But I got this right. SFD.
Can you share your Instagram/WhatsApp number?
I don't do what...
I don't want to disturb your study session. Let's get in touch later.
I don't do WhatsApp. I know that's really strange, but Americans actually don't use WhatsApp. And there's actually a really big negative connotation. People in America think that WhatsApp is filled with like scammers and like bots and like a whole bunch of things, whatever. But you can find me on Instagram, and my I don't know what channel you are watching on. I think you're watching on Tyler Lamond. If you go to Instagram and just look up Tyler Lamond, you'll find it. I don't think I have any posts on there or anything, but you're more than welcome to message me on that Instagram account. What are the 5 fields of the Ethernet header? Okay. 2 left. What is another name for a MAC address? Oh, the burn. It's burned in. Burned in address. First blank address or bits of a MAC address are.
How many channels are you streaming on the same time?
I'm just streaming on 2. I have so what originally happened. Hold on, let me answer this last one and I'll talk to you about that. It's 3. Done. Sweet. So what originally happened, I'll just give you a quick little lore. Is that I used to make drum videos. Like way back in the day. And then if you go far enough down, this was my original channel. And I made drum videos. And then I started making video game videos. And then I started making like tech videos. But I didn't want that to be this channel. So then I started this one. Where'd it go? So then I started this one so that way all my tech stuff could live by itself. But as you can tell, like this is very, very new. Like I don't even think I have videos on here that are 1 year old. Yeah. So it's very, very new. So I'm technically streaming to both channels right now to get people who went to Paradiddle Pete for tech stuff to get them to come over to Tyler Lamond. And eventually Tyler Lamond will be all tech and Paradiddle Pete will be no tech and it will be just like video game stuff. If you like video games things, you can go and check that stuff out if you want. But you don't have to. But yeah. So that's why I'm streaming on 2 different channels right now. Trying to move because I streamed my entire study session for A+ and for Network Plus on Paradiddle Pete on the gaming channel.
I am an audiophile and I listen to a lot of songs.
Yeah. Yeah, it's pretty cool stuff. But I think we're just about done. I hope that you guys learned something. I hope things are going well. As I already pulled this up, but I'll pull it up again. If you haven't already, please like and subscribe. Like the stream, share it with a friend. Subscribe to the channel. If there's things that you want to see, let me know in comments. Like people in this chat asked me to make some videos, and I'm gonna make some more videos and stuff. I got a lot of things planned, and it's just a matter of like slowly getting them out. Yeah, dude, Halo Combat Evolved is one of my favorite games of literally all time. Yes. But anyway, like, subscribe, all that good stuff. Share with a friend. And that's it. That's it for the stream. We have another stream coming up. Another study session, which is going to be this one. We're going to do day 6. That's going to be on Thursday at 8 a.m. My time, Thursday at 8 a.m. Okay. There will be a gaming stream tomorrow at 8 p.m. my time. We're going to play High on Life 2. So, yeah. That's all I got for us. Thanks for hanging out. Really appreciate everyone being here and hanging out and the subscribes and the love. I appreciate all of it. Thank you so much. And make sure you subscribe to Jeremy Tech Lab. So if there's no other further questions, I'm gonna cut it there. Later, dog.